Hello everyone. Today I will cover one interesting topic which brings uh, differences between uh, Mathf and System.Math. Um, these two classes looks very different, very simple. Looks very similar from the first look, but if we look in performance, we would start seeing differences very quickly. Firstly, I noticed that in forums people are keep saying that System.Math is much faster and that um, Mathf is just referencing System.Math, but is doing nothing else, just that in terms of floats. And it was until I built this example and I found myself that it is true. So let's go ahead and look what I have. Firstly, I have empty scene, and there is just single script math demo mono, which is attached to my camera. Now I have this script open, so I'm using something here, and I'm using, okay, let's say I'm using, as for example, to calculate angles between two vectors. And to calculate angle, we need several things to do. We need some trigonometry, some square roots, cosines, and so on. And to look at this problem a bit more in details, I wrote this example, which fills two lists with random vectors. So once it's called awake function, it creates two lists, and it fills with completely random numbers. When awake is finished, it's getting started update function. And there are two cases. There is one case when I'm calling to calculate angles through default vector3 dot angle, and another one is my own written angle 3D function, which is calculating angle from my own calculations using doubles. So once I'm filling up these hundreds of thousands of vectors into these arrays, I'm running these calculations with angles to see performance effects. So first, if I'm running get angle Mathf, it's only running at this time if manual, if boolean value of is manual is being false, then I'm running get angle Mathf function, which is this one. So it loops again over i's up to the n, and it calculates this vector-free angle in a regular way. Otherwise, if it is not false, it means it is true, is manual is true, it runs this function, which is get angle System.Math. And this time it's the same loop, but angle is calculated not through vector3 dot angle, but through angle 3D, my own function. Now let's look a little bit more in details about this function, what I'm doing here. I'm feeding firstly these two vectors in a very same way like I do with vector3 dot angle, where two vectors A and B. Now I'm getting components of these two vectors, so it would be and I'm writing them into doubles. I'm reading them from floats and writing them into doubles. So AX, AY, and AZ. So these are coordinates of these two of vector A, and the same for vector B. Now to get angle calculated, firstly I need dot product. So it is firstly x's multiplied by these two vectors ax, bx, then y's multiplied, so ay, by, and then z's are calculated. Sometimes it's difficult to memorize this one. It looks just very simple equation written in this way. But it's difficult to memorize and to remember what is actually this dot product. Yeah, so it's kind of easy sometimes to have it somewhere between your functions and just to look how it looks like. Then there are these sizes of these vectors. Sizes probably are easier to remember. Ax square plus ay square plus az square, and taken out of square root. The same repeated for b vector to get the size of vector b, or magnitude in other terms. And finally it's calculated cosine proof. Everything runs this times proof System.Math, which operates with doubles. And then it finally calculates this cosine and the angle, because it would be in radians, so I'm calculating finally angle and returning it as float. Now when Unity calls vector3 dot angle, I don't know how this function looks like, but what I suspect that it uses all these operations in floats, and it keeps translating between float and double one way and another. And every single operation, for example dot product, then these square roots, every single operation is being translated all the way to the System.Math to get it. And finally, so basically these two square roots and arc cosine to get the final angle. Now to make sure that I'm talking correctly, I made a quick example just for to check if numbers are correct, if angles are being calculated correctly, because this is the first thing to do, because otherwise there is no point to write this kind of function if my angles would be calculated incorrectly. So here is a function getAnglesDebug, which is called after Aresa field. It's calculating angle by these two vectors v1 and v2, firstly by using regular Unity vector 3.angle, and then it's calculating a2 by angle by my function which I just discussed. And at the end it prints out first angle, then second angle, and then difference between these two angles. So if number is low, it will be 150 results printed out. Let's go ahead and look how it looks like. Run. That's it. And it doesn't run somehow because I think I forgot to open it up. Now let's run it again. And now it's filled up. So firstly, we see that these numbers, the first number is from vector free angle, the second number is from my function, and the third value is difference between these two values. So I immediately see that the difference is very small, it is negligible, and the difference is only because it is calculated in double precision. And the difference only appears because of the last float digit. It sometimes appears and sometimes don't. If it doesn't appear, it means that the last digit matches. If it doesn't match, it appears negative or positive one. So it can be plus minus error for the last digit. So here it prints out like 24. It probably saves the last digit, but it doesn't print it out here. So that's the key thing. For example, here it's printed out 37 and 38 at the end of these numbers. So angles are calculated correctly. All these angles are calculated correctly. And there are 150 entries printed out. Next, I want to check the performance. I don't want to print out anything else because I checked that my function is working correctly. I want now to check performance with very large number. Let's say 150,000 entries. It will fill these two arrays with random vectors, and it calculates all these angles based on what random numbers are entered here. So now I have one more thing here. I have this is manual, which by default is set to false. So if is manual is false, it's calling get angle Mathf, which is this one, which is a regular way. If it is true, it calls System.Math. System.Math is this my function, and it can be one way or another. It cannot be anything else. But I also have entered a way that I could switch between true and false and would see on a real time which function is more heavy. So let's save it and let's run it actually to see what do I mean. Click run. Oh, and here I am also printing out in the same way. If is manual equals false, it is printing out Mathf is on, and else System.Math is on. So it's printing out what is currently running on. So if Mathf is on, let's look what we have here. We have about 20 FPS count. Now it's the magical moment, because I press A and it switches to System.Math. And when I do so, I look at FPS and I see 50 FPS. Previously it was 20, now it is 50. It is very clear that calculations which runs through System.Math are running just much more faster than through default vector operations. So I gain about 2.5 times more performance here with System.Math than with Mathf. I can keep clicking. For example, I can turn back Mathf and I see again this 20. If I click System.Math, it will be again 50. And all angles are being calculated correctly. So that's it. That's the proof that System.Math can be running some calculations much faster. And if you see that in your calculations something goes a bit weird, something goes quite slow, there is always possibility to think that it can be a fault just because it's calculating through many typecasting operations which are built in, and you can rewrite things manually and do it in a bit faster way. And this is relatively very easy way to do, because you don't need to build DLLs, you don't need to write things in multi-threading and other things. You can just get more performance just by rewriting a simple function like angle calculation to get 2.5 times faster calculations. Many functions which are in Unity, especially with vectors, most of transform functions are possibly running through this typecasting curse, which is always draining down a lot of performance. And probably there are quite a lot of areas which can get improved. So I hope this example will help you to get to the point how to get your game running faster on Unity. Yes, and that's it. That's my conclusion. I hope you like it, and see you next time. Oh, and this will be also the code I will put somewhere on the web, on Dropbox or on GitHub or somewhere else. So it is free code. So thanks for watching, and see you next time.